All right, so remember our formula for Pearson's R? Today we're going to just practice with a couple of kind of true-to-life examples. But here's our critical value table. Which column are we using? The middle one, the 0.05. Unless we're told otherwise, we're going to use the 0.05. And what does the 0.05 mean? It stands for 95%, but what is 95%? We are 95% confident that what?
Our data is correct.
That there's there is a correlation.
And the data is reliable.
And that it's reliable. Good. That there isn't just some weird data here that's throwing it off. Okay? And notice as the numbers get bigger for the degrees of freedom, those values get lower, okay? And that's because the more data you have, the less likely one weird data point is going to throw it off very much. Does that make sense? Okay? The other thing here, notice, we're talking about things being statistically significant, okay? So you'll notice if you think about those ranges of values, some of these are pretty weak as far as our general categorization. You know, weak was like below 0.5 or something like that. We have a lot of these that are below 0.5, but they're still significant from a statistical standpoint, okay? Now, another thing I will say is we're looking at correlation on a very, very, very basic level, okay? And even the way we're interpreting it and determining significance is a little different than what you would do in an AP Stats class, okay? So you're going to be doing kind of two different things if you're taking that. But the principle is kind of the same, and what you're trying to test is the same, all right? So I have some data here from the first year that I taught SL. And we'll just read it here. Some of the students in IBSL had a number of absences for various reasons. It seems like missing a lot of class time would negatively impact their score. Data for the 32 students I had that year is shown. Obviously, there are names here. Okay?
What is this the actual amount of absences?
Yes. These were actual data from... These are actual data from 2 years ago, okay? The absences, their exam score, which remember your 2 papers of the exam are 90 points apiece. Okay, so total it's out of 180, all right? And then the IB grade they got at the end, okay? Now, like I said, they were absences for a number of reasons. Some, like one, played hockey, so they were constantly having to go to tournaments here or there. Others were a little less legitimate, like I feel like leaving a week early for Thanksgiving and coming back a week late, and for Christmas, and for Easter. Okay, that didn't turn out too well for them. Others procrastinated on their IB art and skipped school for 2 weeks basically, or 3 to try to catch up on their IB art. No, this was 2 years ago. But anyways, so there were a lot of different reasons. Some legitimate. There was one person who had kind of an extended illness, but regardless of the cause of the absences, we would expect the more absences you have, the lower your grade's going to be. Now, is that true in every case? Obviously not. You'll notice, you know, we had one person here who had 44 absences, but they still got 102, which isn't horrendous, okay? But then down here you have people who only had 21 and 22 absences, and they got the lowest 2 scores.
Wait, I'm confused by what the middle one is. Like I get the IB grade, but what's the exam grade?
That's out of 180 on the 2 exams, the paper 1, paper 2, they're each 90 points.
And
So-
what's passing again?
Passing
In
for
like up to 7.
for SL, if you get a 3 on an SL class, and then you get a 5 or higher on an HL class, it'll still count as passing. On an HL, a 3 is not passing. Okay? And if you got 4s on all of your HLs, a 3 would not be passing on any of your SLs. Partly because you need 24 points total. So if you got 4s and everything and a 3 and 1 out of 6, I mean that's only 23 points. So, but let's think about this here. And before we calculate R, why can't we find a correlation between the number of absences and the IB score? Why can't we do that?
Because maybe the values is only from 1 to 7, like it's not that big of a range.
It's not because of the range. There is something with those values, though. What?
Maybe just because like you don't know, there's like an unknown variable of how much time they actually spent preparing for the exam. So if someone missed a lot of days, they still could have been doing the work. But even if you were here, you couldn't have been like attentive.
Okay, well that would impact the results. That is a factor you could discuss, but that actually is not why we can't do a correlation. That might determine kind of the reliability of our correlation or something like that. Think about our data.
It's only one class? Nope, never.
When are we allowed to use Pearson's R for correlation?
Isn't it when it's frequency?
No, not with frequencies. Put that away.
There's like
Put
a
your laptop
ratio.
away. You don't need that right now. What?
There's like a ratio between them.
When there's ratio data or
Like interval.
interval data, okay? In other words, you have to have data where, if you remember, it at least has to be interval. An interval, remember, was when there is a set interval of value between each of the numbers, okay? For example, the difference between 10 and 20 absences is the same as the difference between 20 and 30 absences. Those numbers have meaning, okay? And it's a set distance between each number. The difference between an IB grade of a 4 and the IB grade of a 5 is not necessarily the same, even within the same data point. Okay? For example, look at these 4s and 5s. Here, from a 4 to a 5 was 7 points on the exam. But with this guy, from a 4 to a 5, it was 17 points difference.
If you say that 4 is like this range and 5 is this range, and if they're the same, would that be okay?
Well, but that wouldn't be interval data, okay? If you're kind of treating it almost like a classification. All right, something in there is going to be in this class. So you would have to actually look at this IB score or the IB grade either as, if you're thinking of it that way, as kind of a classification or nominal data, or you could think of it as ordinal data. Okay? Remember, ordinal data has to do with like order or a rating scale. Okay, if you were thinking of this kind of as a rating scale, 7 is the highest rating you can get and 1 is the lowest, then, you could think of it as ordinal as well, okay?
So we cannot have it because the interval between two IB scores are not the same.
Yeah, you have to have interval or ratio data, okay? So now, the next thing we have to look at is the independent and dependent variables, okay? So you'll notice here I put that the independent would be absences and the dependent would be exam score. Why would I put those and not the other way around?
Because, like, the number of absences determine the exam score, but like your exam score like has no effect on like the number of classes you have missed.
Your exam
It's like
score
cause
is,
and effect, not effect and cause.
and like your exam score is dependent on how many absences.
Or maybe just absence.
Okay.
Yeah.
Yeah, and again, we're not looking at cause effect, all right? I know it's easy to say that we're not looking at cause effect, but we are talking about influence. You could talk about it is a factor. The number of absences that we have has nothing to do with what we had gotten. You know, we didn't miss days. That wasn't influenced by what we got because, I mean, for one thing, it happened before the exams. But we are considering, is there a relationship where the number of absences has an influence on the exam score, okay? So, the absences is independent, the exam score we're considering as something that's dependent, at least in part, on the number of absences here, okay? So, it can be an influencing factor here, not a direct cause effect, but it can have an influence. Alright? Does that make sense so far? Alright, now, take a couple minutes here. I'm going to zoom the data a little bit so you can see it better. Okay. Can you guys see that alright? It is on the PDF of the notes if you want to look it up. Alright, I'm going to pause the video. Take a look and try to calculate R.
That's
All right,
not
so-
in our notes, right?
What?
That's not in our notes, right? That example.
Yeah.
It is.
It is in your notes.
Of 21B.
This is in day 9. We're on day 9 here. Okay? So let's run the report here. We calculated R using the formula. We should get a negative 0.411, which made sense because we would expect that as the number of absences increases, the number or the IB exam grade is going to decrease. So it should have a general downward trend. Okay, if we're looking at absences
When we say it's relatively weak,
and exam score. We could say that. What we're talking about here is statistically significant, okay? Those kind of guidelines the book gives are decent guidelines, but the fact of the matter is, if you've got a 0.9 for your R even, if you got that with only like 3 pieces of data, that still might not be enough to say that that is statistically significant. In other words, when we're talking about significance, we're talking about this is likely the case in reality. We could push this result out and try to predict on future events here. Okay? The more pieces of data, the lower your R value has to be in order to maintain significance. Okay? Now, let's run through our hypothesis test. First of all, what is our H sub naught?
That
I forgot what that meant.
if you
That
miss
like
days, there is no correlation.
There we go. There is no correlation.
how do we know that?
It's that. It's
H sub naught, we're always assuming no correlation. There's no correlation between absences and exam scores. Okay?
So H sub 1 is like there is correlation?
That's right. H sub 1 is that there is a correlation.
So these are kind of like guidelines we follow. So for anything, it would be there
exactly, yeah. But obviously don't use X and Y, you would relate it to the situation, yeah. Okay? So now, we had 32 students, what's our degrees of freedom? Degrees of freedom is always,
It's 32 minus 2.
yeah, it's always n minus 2, so it's 32 minus 2, so in this case that's 30. Alright? So now we're going to look back at our table. Okay? We look back at our table, and what do you have in the 0.05? If you go back to the previous slide, what do you get for the 0.05 when there's 30 for our degrees of freedom?
0.349.
0.349?
Yeah.
Okay.
How do we calculate that again?
We're not calculating that, you're picking that out of that critical value table that was on the previous slide.
Okay.
Okay? Now, that gives us our region of rejection. Alright? Let's make sure we understand what this region of rejection means. This is a range of values. R is greater than 0.349. If the R value we get falls within that range, and we're talking about absolute value of R, okay, is greater than 0.349, if it's in this range, then this is the region of rejection. We're going to reject H sub naught. Okay? So, because the absolute value of negative 0.411 is actually greater than 0.349, we reject H sub naught. Okay? We're going to reject H sub naught, and therefore we're going to accept that there is a correlation.
And so the region of rejection is given to us in the previous slide.
Yeah, you're going to have to pick it out of the table based on the degrees of freedom.
Okay.
Okay?
So
You
we
look
go
at that table,
number 32 or 30.
30.
We go to 30 and we pick that number.
Yeah. Mm-hmm. So we would say that there is a correlation between absences and the exam score.
So that's our conclusion.
Yes, that's our conclusion. Now, if you want to describe it as strong or weak, you can.
How do
But-
we know if it's strong or weak?
Yeah, the way you tell is not necessarily what the actual value is, as much as how close to that critical value it is. If it's just barely, okay, then, we could say it's, that there is. But the main thing is here, we're not really concerned with strong and weak, as much as we are significant. And again, significant means we could then use this to try to make a statement about the future. Hey, if you're absent a lot, it is likely that your exam score is going to be going down. Okay? That's the statement we could make. It's not a cause and effect. We're just saying there's a relationship here. It's likely that this is going to happen the more you are absent from class. Okay? Does that make sense?
Yeah, this makes sense. So we always put for the region of rejection, R is greater than or equal to the number we find on the table above.
Exactly.
And on the quiz and test, you'll give us the table. Right?
Yes, I would give you the table and I'm going to give you the formula as well. So, okay?